To demonstrate how we can color-code words in context, we will use William Wordsworth's poem Daffodils as a text and a table containing the 200 most frequent English words as keys. The table contains information on part of speech, rank and frequency in the British National Corpus, word length in letters, the language family in which the word originates, and the period of first attestation. First, we select one of these attributes from the table or use the default key frequency, which corresponds to the number of search matches for each key. Next, there are 3 different data type modes to choose from, which will have an impact on the way in which you can color code your text: numerical, categorical, and ordinal. Let's start with numerical. For this, we will use the attribute frequency in the British National Corpus. In numerical mode, you can specify the start and end color of a color gradient, along which the unique values of the selected attribute will be mapped. In our example with the attribute frequency in the British National Corpus, this means that keys with a low frequency will be mapped more towards the left end of the color gradient, while keys with a high frequency will be mapped more towards the right end of the color gradient. By clicking on the 2 fields below the gradient, you will open a color picker. This allows you to edit the start color or end color, and the color text will be updated automatically. You can also select a color for all words in the text that do not match any key. This can be useful for several applications. For example, you can reduce the visibility of these unmatched words in the text by selecting a light grayscale color, so you can focus more easily on what you're interested in. Or you could use this feature for language learning and teaching, using a table of all vocabulary learned so far to highlight all words in a text that you haven't learned or taught yet. In the second data type mode, categorical mode, WordValue will automatically gather all unique values from the attribute you selected and provide you with the option of assigning an individual color to each unique value. To demonstrate categorical mode, let us choose a different attribute, namely the language of origin, which we coded as origin language family in our table. For this attribute, we have 4 categories: words of Germanic origin, words of Romance origin, words with both Germanic and Romance origin, and a category for any other origin. By mapping these categories to colors that are in contrast to each other, we can quickly get an intuition about the distribution of different languages of origin in a text. As we can see, most of the search words found in the poem are of Germanic origin. Finally, ordinal mode offers you a combination of numerical and categorical modes. To demonstrate this, let's choose yet another attribute, namely the period of first attestation. In ordinal mode, you can specify an ordering of your categories, which will be used to map these categories to the selected color gradient. This is especially interesting for attributes which have an inherent ordering, such as the ordering from small over medium to large, or in our example, the period of first attestation, with values from Old English and Middle English to Early Modern English and Modern English. As you can see, the categories are automatically mapped in an ascending order. As such, words of older origin will be mapped to the left end of the color gradient, while newer words will be mapped more towards the right end of the color gradient. Like in numerical mode, you can also edit start and end color of the gradient. Additionally, you can edit the ordering for your categories by selecting an order from a drop-down menu. For now, let's leave this as it is. We can now see from the colored text that most of the search words found in this poem already existed in Old English.